So chapter 9, section 5 is the sine and cosine ratios. This is going to be 3 trigonometric functions. Or, in other words, just 3 different ratios. So, we have the sine and cosine. We learned tangent last class, and today we're going over sine and cosine. So, for triangle ABC, let it be a right triangle with an acute angle A. The sine of angle A and the cosine of angle A, written as sine A and cosine A, are defined as follows. So, sine A is a leg of the opposite angle, the opposite leg from angle A and over the hypotenuse. So, in this case, it would be BC over AB. And the cosine A is the length of the leg adjacent to angle A, length of the hypotenuse. So in this case, it would be AC over AB. Now in this case, they show you how sine A is opposite hypotenuse and the cosine of A is adjacent over hypotenuse. The same for B. B would be a different color. So for B, opposite is the sine and the hypotenuse is C. And for the cosine is the adjacent and the hypotenuse again. So it's always going to be the same ratio. Again, it's based on the angle that we choose, just like for the tangent. So this is an acronym to help you remember the ratios. It's SOHCAHTOA. So I'm going to write here that it's an acronym. To help you remember the ratios. So, how does this help you remember the ratios? So we have SO, CA, and then TOA. SO is the sine, so the first letter is what the function is referring to. So in this case, it's the sine. The second letter is opposite, and the third letter is hypotenuse. It's always going to go in the order of second to third, being the 1 over. So for sine is opposite over hypotenuse. The CA is CAH. Again, the C referring to the sine, A referring to adjacent over hypotenuse, and TOA, again, the T referring to the tangent, which is the function, and then that equals opposite over adjacent. This is what we learned yesterday. So here we have example 1. They want you to express A, so sine A, cosine A, and tangent A. And for B, sine B, cosine B, and tangent B. Now, I'm going to write in the acronym. So, SOHCAHTOA. I do want to mention that SOHCAHTOA is only for the acute angles. So, only for the acute angles of the triangle, not for the right angles. So not for the right angles. Now for angle A, the opposite, so let's start with sine of A. We know it's opposite over adjacent. The opposite over hypotenuse, so the opposite is 3. The hypotenuse is 5. For the cosine A, it's going to be adjacent over hypotenuse, so 4 over 5. And then for tangent A, is going to be opposite, so 3 over adjacent 4. Now for sine B, it's going to be opposite from B. Let me do it in a different color. The opposite is going to be 4. Adjacent is going to be 5. For the cosine of B, it's going to be adjacent, so 3 over hypotenuse 5. And tangent is opposite, so 4 over adjacent, which is 3. So, sine and cosine of complementary angles. The sine and cosine of complementary angles is... So the sine of an acute angle is equal to the cosine of its complement, and the cosine of an acute angle is equal to the sine of its complement. So let A and B be complementary angles. The following statements are true. So they're saying that the sine of A is equal to the cosine of 90 minus A, and the cosine of A is equal to the sine of 90 minus A, so it's going to be the sine of B. So if you guys have a triangle, let's call this A, B, and let's call this X, Y, Z. So if we do the sine of A, let's write out SOHCAHTOA. So the sine of A here is opposite over hypotenuse, so YZ. And if it's telling us the sine of A is equal to the cosine of B, notice how the cosine of B is also adjacent over hypotenuse, so it's Y over C. Notice how it's the same ratio. So they're always going to be the opposite, The opposite functions are always going to be equal to each other. The same if we do the cosine of A is going to be equal to the sine of B. It's always going to be opposite to each other. As long as they're complementary, which in this case they will be because this is a 90-degree triangle. So angle A and angle B must always add up to 90. So for example, to the one and you use a calculator to find this. A couple of reminders. The calculator must be in degrees. You guys have it in radians during the test and don't notice, it will still be wrong as we need it to be in degrees to get the proper angle. Also, on the test or the quiz, in this case a test because the quiz already happened, make sure you watch out for rounding instructions. So remember, if it says round to the 4th place, round to the 5th, round to the 10th, 100th, thousandths, make sure you know 10th is the first decimal place, 100th is second, and so on. So make sure you know those terms. If we go past the 3rd decimal place, which is thousandths, we'll start putting round to the 4th and to the 5th decimal place. But make sure you round to what the instructions are telling you. Also remember, to find the angles, you just use the regular button. There's just a few reminders in the calculator. And for when you're finding the angle, you have to use the second button or the shift button to look up the angle. So the second button / the shift button, depending on your calculator. So sine of 30 in degrees is 0.5. Sine of 42 in your calculator is going to give you, cosine of 42 is going to give us 0.7431. If by any chance they don't tell you what to round with, usually go to the 4th decimal place. That's a pretty good bet. We usually round to the 4th unless specified. So now to find the angle of 0.1045, we're going to do second or the shift button, sine 0.1045. And we're going to get that it's going to be going to give me 6 degrees. For the angles, unless specified, try to round to the nearest whole degree. This one is approximately 5.9983. So this one's really close to 6, so I just go ahead and round it to the closest 6. Now for the cosine is 0.9659. The angle is going to be 15. Now, if you were to put it in the calculator, you get 15.0057. So it's pretty good close to 15. So again, I just round to 15. Remember, for this one is sine -1, and then you plug in the decimal. And then for this one is cosine -1, and then you plug in the decimal. Now, for example 3, they want you to find the value of x and y to the nearest integer. So make sure, in order for you guys to get these right, just do one at a time. That way you're not going to get confused, because you have to decide which function to use. Now, make sure that when you find the value of x and y, you're going to have to use you have to decide based on the angle. So I'm going to write up here SOHCAHTOA so you guys have the little cheat sheet to remind you. So look at the picture and see what is given and label the sides in relation to the 28. So doing that, this is the opposite based on the 28, and this is the adjacent based on the 28. That way you're going to be able, and this is the hypotenuse. That way you're going to be able, after you label them, to choose the correct function. So I'm going to write that down, what I just said. So you look at the picture to see what is given. And label the sides in relation to that angle. So since we're doing it based on the relation to the angle 28, and we have we have adjacent and opposite that we want to choose, and we are giving the hypotenuse, I want to make sure I use sine and cosine, because those have opposite and adjacent, and we have the hypotenuse. So if I do sine of 28, the opposite is going to be x, which is what we're trying to find, over the hypotenuse, which is 1,000. Now, in order to solve this, I'm going to multiply by 1,000 on both sides. So I'm left with 1,000 sine 28 is equal to x. Now, I plug that into the calculator. And that's going to give me that x is equal to 469.47. Or we can leave it rounded as 469. Now, in order to find y, I'm going to do the same thing. The y is adjacent to the angle. So I'm going to go ahead and choose the cosine of 28 equals adjacent over hypotenuse. I'm going to go ahead and do the exact same thing, multiply by 1,000. So I'm left with 1,000 cosine 28 is equal to y. So when I plug that in, I am left with y equals to 882.94, which is going to round to 883 if you want to leave it to a whole number. Now, you can also use the Pythagorean theorem to check or find the last side if you have confidence in your first side. So if you guys were happy with the 469, you could have done 469 squared plus y squared equals 1,000 squared to check or to find the other answer. But if you have a calculator, I would recommend you using a SOHCAHTOA. It might be easier, less numbers to plug in, and it's easier to solve at the end. But if you're not confident, you can always check your work with the Pythagorean theorem. For example 4, they want us to find it to the nearest degree. So that is the rounding instruction. Remember to use the inverse to find a degree.
So in this one, the inverse, we're trying to find the inverse of x. Or we're trying to find x.
So since you want to find x, which is an angle, everything is in relation to this angle. This side is the opposite from x, and this side is the hypotenuse, because it's across from the 90. Now, if we use SOHCAHTOA to figure out the function that we're going to use, we need opposite and hypotenuse, so it's going to be sine. So if you do sine x equals, we have the opposite over the hypotenuse, which is 30. So since we want to find the angle, we actually have to use the inverse sign. So it's going to be sine to the negative 1 power equals 18 over 30. And that's going to give us, when you plug it into the calculator, make sure you use the shift button it's going to give us about 36.8, which is going to round angle X to be 37. 37 was the instruction to the nearest whole degree, so that would be our answer. So for example 5, they want us to find the measure of the three angles. They want us to write to the nearest tenth. Now the first thing to notice is that this is not a right triangle. So I'm going to write that down. Again, how do we make it a right triangle? We're going to draw the line from the A to the base, which in this case is BC. And it's breaking up into we're going to break up the segment by a bisector. So that means that the base is going to be 2 and 2. Now, we're going to have to choose one of the two triangles. So I'm going to choose triangle with the side AC. And then I'm going to find the angle C. So let's say I'm going to write SOHCAHTOA on the top. Now, after writing SOHCAHTOA, we realize that we have the adjacent side and the hypotenuse of this new triangle. So, because we have the adjacent and the hypotenuse, I'm going to actually choose the cosine of C to be 2 over 5 in order to find the angle. So, to find the angle, I'm going to plug in cosine of -1, 2 over 5, and that to the nearest degree is 66 degrees. Again, they asked for the nearest tenth, sorry, so 66.6.4 degrees. That is our C. Now, if you guys notice from the original triangle, these two are congruent because they're both equal to 5. If you guys remember properties of isosceles triangle, you remember that angle B and angle C are going to be the same. So I can say angle B is congruent to angle C because they're isosceles. I'm going to write that in so you guys have it. So since we know that they're equal, I can actually just go ahead and do angle A equals 180 minus 66.4 minus 66.4. So that's going to be 180 minus 40. So angle A ends up being 47.2 degrees. So we have sine and cosine in special right triangles in example 6. So to find the sine and cosine of a 45-degree angle, since it's a 45, 45, 90, this is a special right triangle. The sine again is opposite over hypotenuse. The cosine again is adjacent over hypotenuse. So it's always the same way. So if we do the sine of 45, doesn't matter if you go from this 45 angle or from this 45 angle, because it's going to be the same every time. Now the opposite is 1, the hypotenuse is √2. Now remember in math, we don't like to have the square root at the bottom. So I'm going to fix the radical by multiplying times √2 on the top and the bottom. So that would give me that sine of 45 is √2 over 2. Now if I do the cosine of 45, is also adjacent, so over hypotenuse, so 1 over √2, multiplied by √2 on both. And that will leave me again with √2 over 2. So if you notice the cosine and the sine for a 45, 45, 90, again, this isosceles triangle in particular is the exact same. It is not the case for the 30, 60, 90 triangle. Here they're asking for the sine and cosine of 30. So the sine is opposite over hypotenuse. So for the sine of 30, we have the opposite, which is 1, and the hypotenuse, which is 2. So sine of 30 is 0.5, a half. We're good from there. Now the cosine from the 30 is √3 because it's adjacent over hypotenuse, which is 2. So again, it does follow the same tricks and the same steps. But for a 30, 60, 90 triangle, I don't have to give you two pieces of information. I can just give you the angles. And you guys should be able to fill in the rest because these are special right triangles that we already learned. Now we have the angle of depression. So the angle that a downward line of sight makes with a horizontal line. So you remember before the angle of So the angle of elevation is the one you learned before. That was the one that when you were standing there, it was from your eyesight up. Now, the angle of depression is the opposite. So this is not what we're doing with right now. The angle of depression is from your eyesight when we look down. So if you guys think about it, if you're at the top of the hill, say you're here, and the horizon for you is this way, and you're looking down the mountain, that is the angle of depression. So we have the angle of depression, which is example 7. It states you're skiing on a mountain with an altitude of 1,200 feet. So this is this altitude right here. And you are the skier at the top. The angle of depression is 21 degrees. So you know it's from the skier towards the mountain. So it is already written for us, but it's just so you guys understand. And they tell you to find the distance of x, distance x you ski down the mountain to the nearest foot. So they want us to find, in this case, the hypotenuse. Now, looking for this angle, we have the opposite information, and we have the hypotenuse. Remember, the hypotenuse is always across from the 90 degree, which in this case is that one. So, from Sokotoa, the one that is opposite, has an opposite, and has a hypotenuse is sine. So I'm going to go ahead and do sine 21 equals opposite, so 1,200 over hypotenuse, which is x. Now, remember, you can move this around like a normal equation, so I'm going to go ahead and multiply by x on both sides. So that's going to give me x sine 21 equals 1,200. Now, I want to get the x to be alone, so I'm going to go ahead and actually divide by sine 21, whatever that is. So that's going to give me that x is equal to 1,200 over sine of 21. When you plug that into the calculator, you should get 3348.5. But they asked for it in the nearest foot. So do look at the rounding. So our actual final answer is 3349 feet. So 3,349 feet. That is how far you're going to be skiing down. There's no more questions. You guys have homework on Canvas.
What does it do?
And we would be done with today's lesson.